So we don't always want to have to define a whole nother letter when we just want to say not a certain statement. Okay, so welcome to our section 10, negations. So if we have that P is the statement X is in A, then not P just means X is not in A. Okay, it's just the negation of whatever the statement of P was. So let's talk about what that looks like on our truth tables that we talked about last video. So if I just have my P and Q the same way, and just real quick, you could rearrange where the T's and the F's are and stuff and still have all the combinations, but this is the most straightforward way to make it clear to everyone because people pretty much always write their stuff like this. Okay? So what would not P mean? So if P is true, what's not P going to be? Well, it's going to be false, right? So then we have false, false. And then similarly, if P is false, then not P is going to be true. Okay? And so then not Q is going to be the same deal, where you just take whatever's going on in Q and you just flip-flop it. How about not P? So let me write what I'm talking about. So we have not, so we're nodding, or we're negating not P. Or we're negating the negation of P. So, well, we can just look at this column and just see that we're going to flip-flop everything from there. So we have true, true, false, false. Oh, well, if I take a look at this and this, they're the same. So we can see that P and not P are logically equivalent because their truth values are the same, or their truth tables are the same. Well, how about not P and Q? So let me write it because that might be a little bit confusing. So I mean not P and Q. When I write it like this, what I mean the not is only on the P part. Okay, if I was going to not or negate the whole statement, I would put parentheses like that. Okay, let's get rid of those. So I mean one of these two, whichever one works for you. I'm probably going to keep writing like this just so that I have less that I have to write. Okay, but they're the same. Okay, so to have not P and Q to be true, we need that not P is true and that Q is true. Okay, so all the places that not P are true are there, and then all the places that Q is true is here and here. So the only place that they overlap is here. Okay? So that's going to be the only time that this is true. The rest of it is going to be false. So if you do have something that you want to evaluate its truth table, and it has a not in front of one of the qualifiers, then you could do it like this, where you actually list it out. Or you could just look at, instead of looking at where not P is true, you can just look at where P is false. Okay, because it'll be the same. Okay, fun. Now, how about not P and Q? So we're negating the whole thing. You want to think to yourself, what players do we need? So here I have our P, Q, not P, not Q. So we certainly need P and Q. Maybe we didn't need the nots, but you'll see in a second why I did that. To negate P and Q, well, why don't we just figure out what P and Q looks like, and then we can negate that. So you might remember this from last class, but both of them need to be true, so that's the only one that's true, is the first line. Okay? So if I'm going to negate this statement, then that's going to be false, and the rest are going to be true. So something you can think to yourself is, well, what is this logically equivalent to? Here, the pink represents when our statement is true, and blue represents when it's false. Ooh, well, if I pinpoint my focus on this little box here, it kind of looks like not P or not Q. And if you didn't see that right away, that's understandable. So here's what we have. So not P or not Q. So the first time it's going to be false because they're both false. True, true, true. Ooh. So we have that these are logically equivalent. So now we see that not P and Q is logically equivalent. So I often short equivalent to equiv, to not P or not Q. Okay. Similarly, we have that not P or Q. So that just means I'm saying the same thing as above. So logically equivalent to not P and not Q. Okay. So whenever P or Q is true, we have that either P is true, Q is true, or maybe both of them are true. Okay, so when's the only time that that's going to be false? So then that means that's the only time that the negation would be true. Well, it's only going to be false when P is false and Q is false, right? Because if one of them is true, then our P or Q is true. Okay, so that's the only time that P or Q is false, meaning that's the only time that negation of P or Q is true. We need it to be that P is false and Q is false for this statement to be true. Okay, so that means that it's logically equivalent to this because the only time that this is true is if P is false, meaning that the negation of P is true, and Q is false, meaning that the negation of Q is true. Okay, so that's a lot of words, so try writing it out or something. How about things like P or not P? Or P and not P? What do we get here? So who are the players that we need? Well, we only need P and not P. True, false, false, true. Okay, because we don't have Q, so I don't need more pairs. So if I talk about P or not P, well, I just need P or not P to be true. Wait, that's what it's going to be all the time, right? Because if one's true, the other one's false, and if one's false, the other one's true. Okay, so how about P and not P? Oh man, well that's never going to be true, right? Because they can't both be true at the same time. They're literally the negation of each other. So what's cool about this is called a tautology. And that just means the whole column is just full of T's. So you won't be tested on that, but it's an interesting vocab word. Okay, so on to negating written statements. So I just wanted us to recall the for all symbol and there exists symbol. So here's the list. You could pause it, try it on your own, try to look at what the negation is. If you can just write it in words, I'm happy with that. Or if like concepts or something. You will need to be able to write it with these symbols that I've already mentioned. But if for right now, all you can do is with words, that's okay. By the end of this, you should be able to do it with the symbols. Okay? All right, so 3 is even. The negation of that would be 3 is odd. Right? Because that's the opposite of being even. We're not negating something about 3. We're not all of a sudden thinking about something besides 3. Right? We're sticking with 3. And just instead of it being even, odd. So P. There exists an n in the natural numbers such that n is less than 0. Okay. So the negation of P would be for all elements n in the natural numbers, we have n is greater than or equal to 0. Okay? So notice I switched between the two symbols that we just learned about. Okay? Instead of there exists and n in the naturals. I'm talking about all the naturals, okay? And then instead of saying that n is less than 0, I'm saying that n is greater than or equal to 0. And you need the greater or equal to because that's what's opposite of less than 0, okay? So if this was less than or equal to, then this would just be greater than over here, okay? So you just want to always keep track of that. It's not enough to just switch the direction. You also need to talk about the equivalence in one or the other, okay? So let's think about why this is the negation. So there exists some element such that n is less than 0, okay? So if that were true, we would just say that there's some element in there that's less than 0. Now, if that were false, then negation of p would be true. Okay, so if it's false that there exists just some element in there that's less than 0, then what we want to show is that every single element is greater than or equal to 0. Right? See how they play off of each other? So if there does not exist a single element in the natural numbers that's less than 0, then all the elements in the natural numbers is greater than or equal to 0. Okay, so see how that's the negation of it? So this might be a little bit confusing because you might know that this original statement, P, is false. P, there exists a t in the integers such that t squared plus 4t minus 12 equals 0. Okay, so the negation of this is going to be for all t in z, we have t squared plus 4t minus 12 is not equal to 0. Okay, so once again, if there does not exist a t that makes that true, then what you want to say is every single t in the integers makes it true that that equation is not equal to 0. Right? See how these are opposites of each other or negations of each other? All right, so here P for all y in the rationals. Sorry, there should be a space there. There exists an a and b in the integers such that y equals a over b. Okay, so the negation of this, so before we said the negation of there exists is for all, right? Because if we want to say that there doesn't exist something, then we want to talk about everything, right? Because if you talked about all the integers except for 1, well, maybe 1 is that thing that exists. Maybe that's the one that makes the magic happen, right? So you want to talk about all of them. So here we already are talking about all of them. So if it's false, if you could just find one element in the rationals that this is not true, then it breaks the whole thing. It breaks the for all, right? So the negation is going to start with there exists. There exists a y in the rationals. So notice, every time that I do this, I'm not like changing the set that we're in, right? I still want to be talking about the same concept. Before, I didn't change what equation we were working with, right? We want to keep the same concepts, but just say different things about it, okay? So I'm still saying something about y in the rationals. So I want to say there exists a y in the rationals such that, and now instead of there exists an a and a b, I want to say you can choose any a and b you want, and this is not going to work. For all a comma b in the integers, y does not equal a over b. Okay, so I went from before, so P is saying choose any y, choose any element in the rationals. Then you can find there exists at least one pair of a and b in the integers such that y equals a over b. So the opposite of that, the negation of that, I want to say there's at least one element in the rationals such that choose any a or b that you want. I dare you, choose any of them. You're not going to be able to find one. A and B in the integers such that y is not equal to A over B. Okay, so I hope that you're kind of grasping how these negations are working. Okay, and you might have to, as you saw, I had to change the verbiage a little bit here and there. It's okay, it doesn't have to be perfect. You just want to get your point across to the reader.